welcome on the channel. Today some basics for beginners about flashing timer and delay timer on famous 555. It's really old chip, come on, from 1972. So it means usually the parts from this time is rather not accessible, but this timer is still in producing. Of course, it's many different diagram schematics. Internet is full of them, but sometimes I think it's better to understand the basic of the basics. When you understand how it works, it's easy to play with diagram, build something, and know what's going on and or why not going on. So what do I want to build, because I need it for one of my projects right now. This is like a just flashing timer for LED and delay on timer, power delay on timer. Okay, so let's start from beginning. It means what's inside this small plastic. So this is internal diagram of blocks of this chip. So from left what we see is a voltage divider. It's a 5 same value resistors between ground and VCC. So means everything will happen at 1/3 of 2/3 of roughly of voltage, the power voltage of VCC. Two comparators, flip-flop, output driver and discharge transistor. Output driver allow us to use the maximum 200 milliamps of driving power of current using for powering, I don't know, let's say relay. Discharge transistor is shown separately because it's using for discharge external capacitor. So this is the basics what we have to know. We have to remember only so the voltage, power voltage is from 4.5 to 18 volts. That's it what we have to know. Of course, we can find many information on internet about it. Generally, two basic ways which we using 555 is astable or monostable. This is like an oscillator. Astable is it's produced continuous stream of pulses. Everything is set by these two resistors plus this capacitor. This discharging transistor was for this capacitor, and frequency is set by that. This like for flashing LED, buzzer, something, everything depends on the frequency. Let's check how it works in reality. And it will be powered from 6 with something volts. Let's check it. So we see it's a 6.45. Okay, right now I switch off the power and let's connect two meters. One for output, it will be pin 3, 1, 2, 3 here, yellow testing wire, and for trigger and threshold, which are connected together, so it will be pin number 2. As you see, this pin number 2 going to pin number 6, and it's red one. Oh, it's a green, but here's a red, and of course ground. We connect to the ground. Okay, we switch on you see bottom is output, yellow wire, and top is trigger plus threshold, red one. It shows some millivolts right now. Okay, and I switch on right now the power. Right now, as you see, the output is on nearly VCC, and here capacitor charging. In moment when it reach around 4 volts, output will go low. And in this moment we should see the LED and hear the right now we see how internal transistor discharge this external capacitor, and then when it go to around 1/3 of VCC, it switch change the state of output. It means output all will be high and the LED, and as we will see, this is depend on this external capacitor. This external capacitor right now we have here what we have 100. So let's say we change for something smaller. Of course you have to check it check in the calculator, but we just replace for smaller and we will see what happens. It means smaller capacity should charge faster. Let's say we will try with 5022. Okay, I activate PSU. Of course, first pulse are always longer because we charge from 0 to 1/3. The next pulses are shorter because we charge from 1/3 to 2/3 of VCC. They are not equal because to do this we have to calculate two resistors more. Okay, let's change it for even smaller. It's a few internet calculators where you can calculate the output and length of the pulses, etc. I think on DigiKey web page as maybe not the best, but quite good. Okay, so it was astable. Let's try with monostable. And second is monostable. It means when we trigger, it produces one pulse. So this is like more detailed diagram on monostable. We have our pin out. 5 is usually in this mode is a grounded, is decoupling capacitor. Forget about it. It also works sometimes without it. We have switch for triggering. Threshold and discharge are connected together, and the brain of this wiring is this set of resistor and this capacitor. How it works? Like we know, everything will change at 1/3 or 2/3 of VCC. So when trigger input is above the trigger level and threshold input is above the threshold level, the flip-flop is reset and the output go low. If the trigger inputs follow below the trigger level, the flip-flop is set or reset and the output goes high. Of course, in our case, we don't want produce one pulse. What I want to do, I want to get one delay, then switch on and keep till I switch off the power of full system. So what I want to do, I will forget about this resistor, forget about this switch, and connect trigger to threshold. We back with this capacitor to the first value. What we have to do, we remove this top resistor. This we switch to the VCC. I think that's all. Let's check it. It's 100. Okay, let's change the capacitor for smaller. Works. So in this case it looks like that. So when we power on, it charges the capacitor, change the state of the output for low, and right now it's reached state high on the trigger. It's connected with threshold, and it will stay stable to the moment we switch off. Is visible this light or not? Till we switch off all systems, means power. Let's try again. And here is smoothing capacitor and half wave rectifier, because I want to power it from 6.3 volt DC. So for this reason, and of course is this decoupling capacitor on pin 5. Okay, let's check it if it works or not. Okay, and here is a delay timer for high voltage in a power supply. Of course, like I said, it was only basics, but when you understand how it works, it's much easier to operate with every diagram, because the possibilities of using this timer like a 555 is a lot more than we usually need. If anybody wants, he can take a look how I weld solder this board. Nothing interesting, but maybe somebody wants. Okay, and of course please like it and leave a comment.